Today we're looking at notes 5-7, solve quadratics using algebra. But before we get started, we have a little recap to discuss on the back. So remember, for example, that the square root of 9 is 3. Well, why is the square root of 9 3? Because the informal definition of a square root is that you're breaking this up into two identical factors, and when you've got two identical factors, you just say the answer is one of the factors. So here we've got 3 times 3 is 9. They're identical factors, so we say the square root of 9 is 3. Similar here, when you break up x squared into two factors, you get x times x. These are identical factors, so we don't say that the answer is just x. Remember, when dealing with even indexes and even indices, that you put the absolute value bars around. Okay, but again, two matching factors. Similar here, when you've got the quantity x plus 5 squared, really that means the quantity x plus 5 times the quantity x plus 5. Again, just like here where you had two matching factors, here you've got two identical factors. So your answer is the quantity x plus 5, but of course, again, like I said, with the variables and with the even indices, you've got the absolute value bars around. Now here's where students get really tripped up. Okay, x squared minus 1, for example. Okay, this, first of all, you can't take the square root of this as it is because there's not multiplication here. You've got addition or subtraction in between. The only way you can take something out of the square root is if you've got factors. In other words, keyword multiplication. Okay, two factors that are multiplying by each other to get back to this. Two things that are multiplied by each other to get back to this. Here, first, you would have to factor this, okay? You can't take the square root of x squared individually, take the square root of 1 individually, and then say, oh, it comes out like that. No, no, no. Okay, you would have to break this up into factors, and the factors of this difference of squares would be x plus 1 and x minus 1. Do those factors match like all of the others? No, they don't. So in this case, you notice I don't have equals anything, because in this case, you just leave it like it is. There's nothing more you can simplify here at this point, okay? So just so you know, a little recap on how square root works, because we're going to be dealing with it a lot here soon. Okay, so let's flip back over. So for the following quadratics, find the solutions, in other words, zeros, roots, x-intercepts algebraically. Okay, so in number 1, here's your problem. I've gone ahead and did these graphs off to the side just so you can see graphically what we're finding algebraically. So let's go ahead and get started here. So of course, the first step we're going to do is we're going to plug in 0 where we see y, and remember f of x stands for y technically. So 0 equals 2x squared minus 8. And we're using algebra, so we're going to add 8 to both sides, so 8 equals 2x squared, right? And then we're going to divide both sides by 2. Okay, so 4 equals x squared. All right, so then we're going to square root. You know what? I'm going to scratch that. I'm going to write a whole new step, and I want you to as well. So that's x squared. So then next step down, we're going to then show the step of square rooting both sides. Okay, so remember I erased this one because I want you to show that as a separate step. Then here, the square root of 4 is 2. And here, the square root of x squared is the absolute value of x. Okay, so then to get rid of the absolute value, you get the plus or minus. So x equals plus or minus 2. Well, let's check the graph. So of course this was the quadratic, shifted down 8, vertically stretched by 2. Yep, that's been done. And so looking at my x-intercepts, are they positive 2 and negative 2? They sure are. There's my x-intercepts, positive 2 and negative 2. How cool is that? The algebra and the graph match. Okay, next example, problem number 2. So, of course, plug in 0 where I see y. All right, to solve using algebra, I'm going to first subtract 9 from both sides. So this will become negative 9 equals negative the quantity x plus 1 squared. I want to get rid of that negative out in front. So divide by negative 1, divide by negative 1. So I get positive 9 equals the quantity x plus 1 squared. And then again, I'm going to come down and rewrite this step because then I'm going to show the square root. And of course, the square root of 9 is 3. And the square root of this x plus 1 quantity squared, remember the two factors are x plus 1 times x plus 1. So this is going to be x plus 1, but of course, because we've got that even index and we've got that variable coming out, we need to put absolute value bars around. So of course, to get rid of the absolute value bars, you'll put the plus or minus 3. Okay, and then here in this case, you have a couple of choices about how you do this. You can go ahead and split it up into two problems where you say x plus 1 equals positive 3 or x plus 1 equals negative 3, because you've got two possibilities, one where 3 is positive and one where 3 is negative. So in this case, x equals 2. And in this case, x equals negative 4. So those are our solutions by algebra. Let's check our graph. So was this the quadratic shifted left 1 up 9? It sure was. Reflected over the x-axis, very nice. And were our x-intercepts at 2 and negative 1, 2, 3, 4? They sure were. How cool is that? So our algebra is verifying our graph. Okay, next problem. We've only got 2 more, so bear with me. Problem number 3. 0 where we see y. 2. Okay. So here, add 4. So 4 equals 2 times the quantity x minus 3 squared. Of course, divide by 2. All right, so now I'm going to rewrite this step because I'm going to square root. Okay, the square root of 2 is the square root of 2. You can't take the square root of 2 and it's not, I mean you can, but it's not a nice, pretty number. Okay, here again, remember, you would have absolute value of x minus 3. And in this case, again, to get rid of those absolute value bars, you get the plus or minus. So now this problem is different from this problem. You split this one up into 2, so you could go ahead and solve and find the integer values, right? Because here we were only dealing with integers. Now this problem, square root of 2, that's not an integer. So in this case, for our final answer, we're just going to take this minus 3 and we're going to move it over, but specifically we're going to put it in the front. So of course, when a minus 3 moves over, it becomes positive 3. So 3 plus or minus the square root of 2 equals x. So you'll always put the integer value in front and the quote unquote not integer ugly number in the back, right? Think you want this pretty number in the front, this ugly number in the back. So this is our answer technically, and I would be okay with you leaving your answer like this, but for the purpose of the problem, here's what I want you to do, and here's what I want you to do in your IP. Now, of course, we've got this graph graphed over here, right 3, down 4, right 1, 2, 3, down 1, 2, 3, 4, vertically stretched by 2. Okay, I can't tell if these values match this. I can't check my work based on this, because I don't know about you, but I don't know what 3 plus square root of 2 is. Okay, so what I'm going to do is I'm going to come over to my calculator, and I'm going to type 3 plus, oops, not y equals, wrong thing, 3 plus square root of 2, right? Here's the square root button right here once you hit the second. So 3 plus square root of 2, which is, and we are going to round to 3 decimal places. So x is approximately, here, I want you to write it under the graph. X is approximately 4.414. And then we're going to have another solution where x is approximately 3 minus the square root of 2. So that's 1.586. Remember, if I round properly, 1.586. So yes, on your IP, I'll want you to do this for every problem. At this point, I do want you to check. I'll tell you when you don't need to anymore. But at this point, I want you to check. So 1.586, yeah, that looks about right there. And then 4.414, yeah, that's really good. That seems pretty accurate to me. So that is a great way to check your algebra. And like I said, at this point, I want you to do that. Okay, last problem, number 4. 0 for y. Okay, x plus 2 squared minus 3. All right, so move over that negative 3 so it becomes positive 3. Okay, and then again, I don't have anything to divide in front here. That's kind of nice, so I'm going to rewrite the problem to show that my next step is to square root. Okay, again, the square root of 3 is just the square root of 3. All right, here we get the absolute value of x plus 2. To get rid of the absolute value bars, you put the plus or minus on the other side. So here we go. And again, this isn't an integer value, so you wouldn't want to split it up to solve. You can just simply move this positive 2 across. Remember, you want the integer value in front. That positive becomes a negative, and then the ugly, quote unquote, ugly number in the back. So this is a perfect final answer right here. It's a perfect final answer, but I do need those decimal approximations so we can check with our graph. So what is x approximately? So negative 2 plus square root of 3, and I'm going to go ahead and since I'm here, negative 2 minus square root of 3. So I've got approximately negative 0.268 if I'm rounding, and then negative 3.732. Okay, so does that make sense? That's a negative, it didn't show up very well. Negative 2.68, yeah, right there. And then negative 3.732, 1, 2, 3, yep, because it's real close to negative 4. So again, once you graph the graph, check your decimal approximations.